Hello, welcome to another episode of Yummy Data Science. In this episode, we will be continuing our discussion of Ggplot, and we'll be looking at density plots. We will be looking at stacked bar graphs, and we will be looking at box plots. So let's get right into it. I'm going to begin by opening up this script file that I have. And as I have done before, I'm going to be opening up the R project file first and then opening up the script, which is something that I have done already. So you can see that the first part of this script is like the ones you've seen in the previous videos. It is reading in the file and it is doing some data transformation. It's filtering for these three DRGs, the diagnosis related grouper codes, and these are all for respiratory neoplasms. Neoplasms is another word for cancer. And the distinguishing part is whether there are complicating conditions or major complicating conditions in them. So they're the same respiratory neoplasms with or without comorbidities and complicating conditions. So let me quickly run the data. So you can see inpatient 2 has 223 observations. So now we are going to be doing a density plot. What is a density plot? Think of a histogram that you have created with really tiny, tiny bins. Uh, and I know in this case, length of stay is in increments of 1. So it's really hard to think about that. Like what would be really tiny bin, less than say 1. But let's think about another continuous variable where it would be like that. Say income. What if you were taking the density plot of income? And income does come in tiny, tiny increments. So think about a histogram that is in these tiny increments, and then think about throwing a wet cooked spaghetti noodle. And this is from this explanation I really like. It's Hadley Wickham's explanation from his book. Actually, it could be one of his co-authors, so I should give his co-authors credit. It's Hadley Wickham and his co-authors' explanation. So think about that histogram with the really tiny bins and think about a wet spaghetti noodle, that cooked noodle that is thrown on top. Now the shape, now then we freeze that wet spaghetti noodle that is thrown on, and then we lift it, and the shape of that is the density plot. So without getting too much into this technical explanation, let me show you, and perhaps that will make more sense. So here in the Ggplot, I'm telling it what data to use. I'm telling it how to map it. So remember, Ggplot is a canvas and we have to tell it what's up, what is across. Well, here the density plot is what's going to be up, across is the LOS. So we've done that and we are giving it the density geom object, and the plus sign means it's simply another layer. And the explanation of layers is that Ggplot works like that. If you think about your one pager visualization, you are now adding in the density plot to your canvas. All right. So here is my cooked wet spaghetti noodle shape. And you can think like, oh, look, this is 5, LOS is 5. So from your histograms, you'll remember that the peak was somewhere around the bar, which was 5 to 7. So that's where we see the peak. So this is really good. And it starts from 3. So that's where the distribution starts and it goes down, down, down. Okay, so you can now see what this wet frozen spaghetti noodle is. And at this point, ignore what it says on the y-axis. An easy interpretation is that the density plot is created in such a way that all of this data under the curve, all of this equals to 1. Okay, so let's say that somehow this was not the shape it is. It was a rectangular, and the rectangle area would be 1. Okay, so you have one dimension, 1 times 1, and the area is 1. So you're measuring area under the curve. And the interpretation of density plot is simply that the area under the curve is always 1. So if you look at other densities, that's how it will be. It will always be equal to 1. Some will be fatter, more spread out. Some will have nice curve, like the central, like your normal distribution. And some will be very tall and skinny, some will be more uniform, etc. But the whole idea behind doing the density plots is to figure out it is to understand your data and figure out what distribution it is so that later on you could do hypothesis testing on it. But we're not talking about hypothesis testing. Let's switch gears and talk about box plots. So a box plot is also very useful for identifying the percentiles and the outliers of your data. And the syntax of the box plot is the aesthetic layer I've given it y is equal to LOS. And I leave it as a brain teaser for you to figure out why I put it in the y mapping as opposed to the x mapping. And the layer that I'm giving it is the box plot object. So let me show you what that would look like. Here we go. And I am going to be zooming this so I can show it to you better. So the thick line is the 50th percentile. And this is from the 25 percentile to the 75th percentile. So you can see there are quite a bit of outliers like this DRG, the stay, sorry, I shouldn't have said DRG, the stay of over 25. So most of your distribution is centered around 5 to, I would say, 7 or so. And there's a fair bit between the last percentile. I want to talk a little bit about these lines here emanating from the rectal area. These are called whiskers. And there's a short line down below, and there's a longer line here. These are called whiskers because they emanate from the interquartile range. So the interquartile range is from the 25th percentile to the 75th percentile. And the way the whiskers are created, the top whisker in particular, let's focus on that. If the interquartile range, the top part of it is around 7, so you would go 7 times 1.4, 1.5, which is about, I would say, 7 point, so 7 plus 4, 11. So it would graph your, I think this is probably more like 8. So if you were to do that, then it would be 8 times 1.5, which is 12. So this is 12. So it's 1.5 times the highest point of the interquartile range. And then the software deems the rest of it as outliers, and so these are marked individually. So the outliers that it's probably thinking about is anything that is over 13, 14, 15, and so forth. So enough about box plots. One thing I'm going to leave it as an exercise is to figure out why we put the LOS on the y-axis. Hopefully by now it is clear why we did that. And in class, I have a teaser, what if we were to map LOS to X? The next thing I want to show you is, just for the sake of completeness, we had talked about bar charts. And now I want to show you a stacked bar chart. So in this stacked bar chart, I am filling in the admission. So I'm filling in the admission flag. And then you will see that this is and the next one is where I'm filling in discharge. So for discharge 1 and 2, you can see 2 means that they went to another facility. So you have a lower counts of 2. 1 means they were discharged to home. And if I go back, I'll be able to see, well, admission is all 3. So I didn't see any variation in this. So this was a short video on density and on on box plots and on stacked bar graphs. Thank you for listening. On to the next one.